Okay, so this is the beginning of lesson 5, and we're working with the version 4 of the database. We had just recently taken the random sample. Right? So we've got our 20,000 observations. Let's go down to the bottom, and we've got 20,653 observations. And I would start a new output file at this point. This is the one that you'll turn in with the project, and so let's do some basic things to make sure where we're at with the sample. Let's start with a couple things here. I've got no output file open, so let's quickly do analyze descriptive statistics. And in this one, I'll just do the dependent variable and that series of interacted variables. And then I also did n other as well. So let's do those and let's make sure that what our sample looks like. And so if you see, we've got 20,653 observations. We have variance. Everything looks to be in order there. The next thing we need to do is we always have to determine what our null category is going to be. So I want to go through and I want to do a series of descriptive statistic crosstab tables, because that's the information we need to know in order to figure that out. So let's go through first, and the thing that I want to do here is I want to put the dependent variable in the column, because that's the thing that's not going to change. I'm going to be looking at the dependent variable for each one of these other situations. And so let's just put firefighter injury, let's put it over there in the columns. Then up there where we did those dichotomous variables, fire control, SNR, EMS, hazard, FRH, systems, assistance, investigation, and standby, right? Let's move those over to the rows, and we're going to click OK, and it'll run a series of crosstab arguments for me. So in this one, we have that 20,000. We only have 63 firefighter injuries, so not many. That's a good record. But let's see if we've got variance in these different areas. So if we look at fire control, we got 59, so we've got a lot there, right? In terms of search and rescue, we've got 8, right? In terms of firefighter injury, EMS, we don't have any. And so EMS is one where we don't potentially have variance on the independent variable, and so it's probably one where we're going to have to, or variance on the dependent variable, so it's probably one we're going to have to drop, right? Firefighter hazards, got hazard times firefighter injury. We've got 2 observations there. That may or may not work. That may be a questionable one. 11 for fire rescue hazard is probably okay. 1 for SNL for systems and services. That's probably a little thin. It may or may not work. You'll see how these affect the parameters in just a minute. Fire assistance, probably going to have to drop that one. IIE, we've got 15 there, and that was a lot of events, right? And so I think this is going to be the one that we use as our null category. Fire standby, we've got a couple there, so we may end up dropping that one or not. I'm not quite sure. Okay. So let's look at this. If we go through this variable, this list of crosstabs, we had 7,000 where we had a fire control event. We had 200. These are really low observation events. 2,032 hazard, 1,800, 500, 1,850. So clearly, the most frequent category is that information investigation and enforcement. Now, that acts as a pretty good null category, because it's the idea of, okay, we sent out crews and they showed up and they investigated, or they were enforcing some sort of code or whatever they were doing, right? That's getting you on the scene. So theoretically, that's a pretty good, null category in a lot of respects. And we do have some observations of injuries there. So what we will do is we'll compare these estimated ones versus this just showing up. So the rate of injury in actions taken, whatever we end up specifying, versus investigating and showing up. So I think that's what we'll do. And we'll probably end up dropping a few. I'll show you how that works here in a minute. Okay, good. Okay, so we looked at these crosstabs and we found the ones that we think we might have a problem with. EMS looks like it's going to be a drop, right? Hazard, we're not quite sure yet. We had at least two injuries there. Same thing for SNS. We had one. We had two there. We had no. So EMS is probably going to have to go. Assistance is probably going to have to go as well because we have 0 there. And then IIE and even FSO we only had, so standby we only had 2. So we want to go through and we want to take a look at these and how it affects the parameters, whether we can have them in the model or not. So let's run our first logistic regression. So let's go to regression, analyze regression. Let's go to binary logistic. And I'm going to reset these and show you how to do it. Let's go down to the very bottom where we created all those new variables. The first thing that we created in lesson 1, I believe, was firefighter injury. All right, so this is our dichotomous dependent variable. And then let's add in our interactive variables. We added into, we're going to leave the IIE as our null category. We kind of decided to do that. And then put in FSONR and click it in there and let's see. Now, if we had just dummy variables, it's nice to go ahead and kind of categorize, use that top bar to categorize them as dummy variables. Gives you a little bit better estimation, and it helps the model, the model climb the likelihood a little bit easier or more efficiently. But in this case, we have regular variance in those. We have kind of an interaction, and it's not just strictly categorical. So we'll just continue there. Save. We can do probabilities and residuals and everything else, and we will be doing that in the future, but for right now we're not too concerned about it. Options, there's some nice things. I think of these, the nicer one is probably the Homer Lemshow goodness of fit. That's not a bad one to look at. The rest of these are kind of different. We may be using this classification cutoff. Right now it's at probability of 0.50 or not. And so because this is such a rare event, logit, essentially, 0.50, 50-50 is probably not a good cutoff value. We'll adjust that in the future. But for right now, we can go ahead with it. We don't need anything with style. Let's just run these and see what we get. Okay. So if we run it, it goes through and does a classification block. We go through, and at least it did predict a few where we would have injuries, right? And so that's something, and that's at a really high cutoff rate. We'll be adjusting this in a little bit, but let's take a look at our parameters. Here we have, remember EMS, we didn't have any observations. So if you look at what that does to the model, we'll have a really big beta and just a gigantic standard error. What that shows me is that that parameter is affecting the model spec. So let's get rid of EMS in the next model specification. Hazard, while it's not significant, right? It's not bad, 0.34. That's not too bad. It shows a little bit of strength. The other one we were potentially interested in was SNS. Well, it's not significant, but it doesn't look like it's blowing up the model per se. The other one, though, where it does blow up is assistance, and we didn't have any observations on that. So looks like to me we need to get rid of EMS and assistance. So if we do those two things for this particular random sample, then we'll have a model estimate that runs fairly efficiently. Okay. Now, you have to remember, when you do your random sample, your situation is going to differ. You may be dropping, you may end up not having any observations on hazard or on SNS or whatever it is. And so you're going to go through this, and whereas I'm dropping EMS and assistance, you may drop EMS, assistance, and hazard. Right? You just need to go through and look at how the model's reacting to the parameter and then go from there. Okay, good. The next step is we'll run it with this one, and then let's take a look at what the model's telling us, and then we can also start working on some probability plots. Okay, so for this last one, we've gone through and we've figured out which variables probably aren't going to work. So let's go ahead and run the final model specification that we're going to work with. Let's save the residuals and predicted values, and then we'll move on to working with those and creating some plots to explain what what we can with the model specification. So we'll work with the predictive values a little bit. So let's go back to analyze reports, or actually not reports. Let's go to analyze regression binary logistic. And remember, we're going to yank out the EMS because it wasn't particularly good, and we're also going to yank out the assistance one, which should leave us variables that at least have enough variance on them to create a reasonable working model specification. Now, categorical, we don't have any categorical variables to specify here. Save this time. I want to save the probabilities, and I want to save the standardized residual values. I may or may not work with the residuals, but I'm definitely going to work with the predictive values. That'll give us a probability between 0 and 1, and we'll plot that in a way to show what the model did. In fact, this one shows us that logit probably isn't the best model to be working with, but yeah, you can learn a little bit from that. And we'll run it this way, and then we'll run it with a model that works better for it in terms of those negative binomial regressions, the event count models. That's just kind of how we're going to run this particular set of exercises. So click OK. Probabilities standardized. That's good. Options. Let's go ahead and do the Hosmer goodness of fit test. And I'm going to change this classification cutoff. All right? So obviously, if you were going to run a fire department and your cutoff for an injury was 50-50, that was a good run, whether 50% injury rate or not, and that's not a very good rate for a fire department. So we need to classify or give us a reasonable cutoff point. Let's say that we're going to use, 95% of the time when we send out somebody, we don't anticipate an injury. So we'll use 95%, meaning that our classification cutoff is going to be 0.05. Right? So if there's greater than a 5% chance of injury, we'll use that as the cutoff and predict that one will happen. Okay, so that's what we'll use here. We'll continue. So the only thing we did there was click on the Hosmer and then change that value to classification cutoff to 0.05. And again, it's because we're using this kind of safety thing, and we use really super high, or actually these kind of different cutoffs than 50-50. Let's click on OK. We should run this thing, and everything should look good. All right, so let's run this. If we go here, let's see what the model did versus the other one. If we go up, page up a little bit, at the very last step, we had 809 as the log likelihood, and let's see what it is now. Yeah, 817. So it went up just a little bit. Let's go through and look at the residuals and what they did. All right, so that's not too bad. We at least step one, we didn't predict, and we had them. Yeah, wasn't the best, but let's take a look at what our parameters did. So what this tells us is that with respect to the null category, that fire control events are significantly higher. Right? We'll look at what that value is. It's about 0.01. Search and rescue is actually higher than that one. Right? Hazard is lower, but it's insignificant. Fire rescue and hazard, it's higher as well, and 0.001. And then these others are insignificant versus the null. So if we're going to try to prevent accidents, it looks like to me we wanted to do search and rescues where we need the kind of most, where you be really most attention and the most at threat of an injured firefighter. Okay. We are also going to be working with some of the residual values that came out of it, actually the predictive values, and I'll show you where those are. So it saved the PRE1 and the ZRE1 at the end of your database. And so let's go up here. We had this saved as version 4. Let's just save it, and we'll go on to the next assignment, or next lesson. Good.